Okay, a lot of students will get really bored with 12.1 and 12.2 and even 12.3 and stop coming to class. And then 12.4 and 12.5, they're totally lost. So I wanted to kind of give you that's coming up. Questions? Yeah, there's actually an error. I wanted to talk to you guys about that. On the syllabus, on the schedule, the online section should actually be moved to the 12.6 extra day, which is actually the April 3rd, which is Good Friday. OTC is having 25, 75, I don't know, is it 25 years? 25-year anniversary celebration, and they said classes after 12 are canceled. Maybe it's after 1. Afternoon classes, and I don't know, I got an email in the start of they're doing some celebration things after noon that they want the faculty to be able to go to. I think they're doing stuff for students too, and there's going to be like raffles and yeah, I think pizza and stuff. So instead of canceling class, I want to put it online, but I kind of got it last minute and I bumped it up 1 extra day. So I'll send an email out just to let you guys know and confirm. We'll actually have class that Friday, but we won't the next Friday. We'll have an online section. We'll probably get ahead and have 2 days for 12.6 anyways. And then we also have this review day. So what I'll probably do with this online section is give you that pretest attached to my email, and then you have that to work on even before the review day, and the review day will just be answer any questions on that or any of the section, any of the questions from the section, and then you'll take that test. The third. We will have it on the 27th. So if you are looking at this calendar, we're moving this online to here. Well, the homework is just for the section. Sometimes we should cover more than one section in a day. But, you know, I probably won't spend too much time on 12.1 or 12.2 and kind of maybe even do some 12.3, 12. That's all review, mean median mode type things, just a little bit of application. We might go a little faster through those so we have more time on the standard deviation and z-scores and things like that. Okay, but thank you for that question. I was gonna. Okay, 12.2, picturing data. This section is not difficult, but it is time consuming. And anytime I ask you to draw a bar graph, you have to draw your x-axis, your y-axis, you have to label your axes, you have to label your chart, you have to label your categories, and then you have to put your bars on there. And it doesn't really tell you anything more than the sentence that gives it to you, or the data points. It's just organizing it so it's nice to see. This is a bar graph. Typically, we have a graph compare amounts or percentages using vertical or horizontal bars, various lengths. So they can be vertical or they can be horizontal, just depending on your setup. But here it's pretty easy to see. We have 4 different categories. We're looking at inventory. Category 1 has 4 in its inventory, 2.5 in category 2, so forth, right?
That would be considered wrong, right? Because it tells you how many to like.
Yeah, it doesn't actually label it what it is. Maybe it would be better to say like amount or something. Right. Typically, you want to see x-axis and a y-axis labeled of what it is, and then the title of the bar graph. A lot of times, some books will actually teach your title is your x versus your y in your title, like category versus the number of elements in its number of items in the inventory, and then the title gives you what it is. But every book presents it just a little bit, what they think is important a little bit differently. But we have a bar graph. You can get all the data from the bar graph. We have pie charts. And pie charts generally give you a percentage, like 5% fit in this category. So they have categories and percentages on there. A little bit more work to go into a pie chart because you have to find the angle. The angle of, to get 58% of the pie, what angle is this? Excel will do these all in 2 seconds. If you have data, you highlight it and say, make me a pie chart, make me a bar graph, and it will do it all for you. We're going to do it by hand. So we might say, what is this angle? Knowing the data point, 58% of the data points fall within this category, so we have to find this angle. And we'll go about calculating the angle, but some of the angles have to be 360. But it will make sense when we look at an example. And then histograms, very similar to bar graphs. Oh, does it not show me? The difference is in a histogram, we're looking at class limits are placed on the horizontal axis rather than categories. So we might have 18 to 20, 20 to 24. We'll have it like a class. So if you fall in between that you're 18 to 20, you're going to fit in this class. Versus a bar graph's a lot of times categories. How many people like cats? How many people like dogs? How many like fish? So that will make sense more with a bar graph. Each topic is disjoined. But a lot of times in histograms, we might use time. We might look at a stock price over time. And we could say a histogram there. Frequency polygons, very similar to a histogram, but instead of bars, we have line segments connecting the midpoints of the classes. So in a histogram, we still have bars. But in a frequency polygon, very exact same setup, but we take the midpoint of every range, or in this case, the midpoint of the classes, like if you're 18 to 20, you take the middle of that, how many of those people fit in that, and then you connect the dots with lines.
It's like the one you see on TV, like if you're in a presentation, right? It's slowly going up.
Frequency polygons kind of give you an idea when things are increasing or when things are decreasing because you're comparing them to each other. Bar graphs are just giving you very specific, very specific amount of data. Time series graphs. This is what I was talking about with the stocks. Time series of graphs, they're going to look very, very similar, but your x-axis is continuous because it's time. So if I'm looking at it's primarily used to show trends like price rising, falling for a time period. All these, yeah, for the stock market. Yeah, if you just look like a time series graph of a certain stock, you can, it's always constantly changing. So you kind of get this jagged. And if you zoom out, it becomes a little more smoother. But we're looking for time series graph where the data being collected over a period of time. So some of these graphs, I can take almost the same amount of data. I can have a bar graph. I can have a frequency polygon, and it can be the same amount of data. The time series graph, though, is going to be continuous from 8 o'clock in the morning to 5 o'clock, 4 o'clock. When does the stock market close? I think it's 4, 3 p.m. And I'm going to have, it's going to be a continuous type thing. But it's all very, very similar to each other. They're used to show trends. You can look at them for a longer amount of periods of time, such as yearly. You can look at oscillating patterns. Maybe they always go up in the fall and always go down in the spring type things. Seasonal trends. So these are very beneficial to people to look at these certain things. Again, what did I give you? 12.2. Okay. I'm going to pull that up in. That's why I opened the wrong PowerPoint. I was like, this is not giving me the pretty pictures.
Restart the class.
Yeah. But let's go I mean, it's going to be the same thing, except we're going to have an extra picture and we're going to have the examples in there. Okay. Example 1. So you're given this information. You're given a category of people's response, how often do you bring your own bags when you go grocery shopping? Always, never, frequency, always, never, frequently, or occasionally. And it's asking you to draw a vertical bar graph to represent the data. Right? You have everything you need, it's just kind of organizing it. So you need a vertical bar graph. So step 1 is to draw the x-axis and the y-axis and label them. So the responses and the frequency of it happening. The title, how often shoppers bring their own bags. And then you just put the frequency on there. You don't have to calculate anything, it's just organizing the data. Make sure you have an x-axis labeled, your y-axis labeled, a title, and your responses, or it's kind of the x-axis. Right?
Will we get points off on the test if we don't, like, say, label everything?
If you don't put, like,
Or the title?
Good question. There won't be a lot of these on the test because they are so time consuming, especially the pie graphs and stuff. But yeah, I'll probably give a point for each label, label the x-axis, the y-axis, the title, because there's really nothing else I can give partial credit for. So yeah, that's going to be worth a point. So if you don't have, this is the frequency, because this could be the exact same amount of data. This could be the number of people that like cats, or the number of people that have a cat, a dog, a parrot, or a fish. I can give you the exact same graph, and then you can just fill in parrot, dog, cat, fish, and then the number of animals they own. There't no math here, though. There's no calculation. Now, there might be some interpreting, like, but
Did you pass around?
not yet. I have it right here. I can pass it around. Any questions on that?
Can we use
I don't know if it's really. I mean, you can on your homework and stuff, but on the test, I'll probably just give you a blank slice, and you can make your own. Because that's part of it, is being able to put your own axes on there, and also just decide, do you want to go by 5s, do you want to go by 10s, you want to go by 50s, depending on the data.
Use your credit card.
It's a straight line. Yeah, if you need something to make a straight line. Pie chart. So this is an example, exact same amount of data, but we're going to make a pie chart. So we have to come up with an angle. We also have to come up with a percentage, right? So this is a little bit more calculation here. First, we need to find the formula for degrees. The number of degrees corresponding to each slice is the frequency over the total number times 360. So in this case, there's 100 people response. So for always, 10 people said they always bring it. So 10 over 100 times 360 is 36 degrees, which is 10%. 10%, 39%, 19%, 32%, which turns out nicely because we have 100. It's not always going to be that way.
Wait a minute. Where'd you get the 100 from?
The 100 was the total number of people surveyed.
Okay.
If you add up 10 plus 39 plus 19 plus 32, you get 100. So there's 100 total responses. 10 of them was always. So if I want the angle, I say what percent responded with always, and I multiply that by 360, and that would give me my angle. And the sum of the angles will add up to 180. So there's 360. There's 360 degrees in a circle.
So we need to bring like a protractor?
No, you won't. I mean, it's not gonna. that's not really the point of this section. You should be able to eye it somewhat, and if you're off a little bit, it shouldn't matter. So some things about angles. This is 180 degrees. This is 90 degrees, right? This is about 45 degrees. This is about 30 degrees, and this is about 60 degrees. So knowing that, you should be able to kind of estimate 36 degrees, right? So if you start, with one of these slices, then say, okay, well, from here, this would be 180. So if I mean 140, right, this would be 90. So 45 plus 90, and then you go around and you get your circle. So we'll kind of do that here. So does everyone kind of see where the degrees come from? You're going to take the frequency, divide by the total number of frequencies, times 360. And that will give you the degree of your pie chart. So I might want to start with 140 degrees. Right? So if I was going to make a pie chart, this would be 90. This would be 180, which is too far, right? But this is 45. So what's 90 plus 45?
135.
135. I need 140. So maybe I'll go like here. And say this is 140 degrees. What I would do on this one, I could give you a pie chart that has different degrees, like maybe marked out every 10 degrees or something. So then you can say, okay, 10, 20, 30, 40, 50, and shade that in kind of region. So you're not wasting as much time if you don't have connection with a lot of angles and geometry and comfortable doing that. The main thing is labeling it.
Well, but then after you do the 140,
Mm-hmm.
then you, like, let's say we do the 115.2.
Okay.
Well, like, our pretty point's already gone.
Yeah.
because
Well,
we
so
already used it.
if this is 140.6, what would this angle be?
Like 45, 39.6.
39.6, right? Right.
Okay.
So I could roughly call that 36. So I'm going to be off a little. I mean, I'm not going to be 100% perfect here. So I could maybe call this in here. Maybe like this. And then I could call this 36 degrees. Right? $68 degrees. Well, we've already kind of eyed 60 before. So 68 is going to be kind of close to that. And if I add this amount, just call this 68.4 degrees. And then the only thing I have left is 115.2 degrees. Right? So then if I erase my x-axis, here, that kind of gives me my degrees there, my angles, right? So if I make a pie chart out of this, key thing here is labeling them. This is 140 degrees, this is 36 degrees, this is 68.4 degrees, and this is 115.2 degrees.
The degrees are then
Well,
always numbers.
yeah, so you could put the names in there, you could color code it. I mean, you're really limited on what you can do with pen and paper. But yeah, you could put them both in there. So this would be never. Right? It turns out 39 people picked never, but you don't need to know that. You just need to know maybe what percent of them.
32%.
Yeah, which would be, it turns out in this one, since there was 100 people surveyed, 10, 39, 19, and 32%. Yeah, so this would be 39% of the pie chart. The point of the pie chart is to give you a visual representation of how much of it is covered by area. So it doesn't really matter if you label on the inside or the outside, being able to, everyone's might look a little different depending on the order they put them in, but the slices should all be around the same size, right? Again, typically on pie charts, you have your percentages labeled as well. So the degree part is actually never really shown, but it's hard to visualize 115 degrees. You guys see that?
We just eyeball it. We're okay.
Yeah, you can eyeball it. That's fine. Some people, that's kind of what I was doing, but I was maybe going a little more in depth as far as like this was 90, so if I go a little bit more, yeah. So you can eyeball it. If you get an idea, this is 360, then you can just kind of eyeball what you need. And like I said, I'll try to come up with some pie graph. They have general forms for pie graph where it marks off every 10 degrees or every 5 degrees. And then that makes it a little bit easier to say, okay, this amount is always, and kind of shade that in. But again, I don't really think there's a lot of benefit from this as far as giving you one of these on a test, because the amount of time it would take to go through and draw the pie graph completely is, I don't want to necessarily test that when I have mean, median, mode, standard deviation, and a lot more applicable stuff as far as being applied to numbers instead of being able to come up with a graph. And in the real world, you have things like Excel that will do this for you with one click of a button. Say, give me a pie graph, and it will calculate all the data, calculate all the percentages to make it nice and pretty. Histograms. This is an example of histograms. Histograms are very similar to bar graphs, except for the fact we use class limits and they're placed on the horizontal axis rather than categories. So the bar graph, we did categories. Category 1, Category 2, Category 3, Category 4, always, never, sometimes. Here we're going to actually do like a class. So there's going to be a range. So this is the example of looking at a stock market price. And they looked at, I guess, the closing price. And they want to draw a histogram for the data. So very similar to a bar graph, except we don't have categories, we have ranges. So if it falls in class 1 to 1.01 to 1.5, how many times did that happen? So frequency of 1, 18, 14, 16, right? So that's the data. The histogram, the bars are going to be touching each other because there's no overlap here, right? The categories, the bars do not touch each other.
Can they though?
Not in a bar graph. A bar graph has very specific categories: cat, dog, elephant, giraffe. What's your favorite animal? There's nothing between a cat and a dog, so they're separate bars.
I didn't know they had to be separate though.
Yeah, that's
Well, I mean, as long as you section them off. And
yeah, that's the difference between a histogram and a bar graph. A histogram is basically a bar graph, right?
okay.
Except the difference is their classes. So the bar represents between 1.01 and 1.05. It has a width, which is very important in upper branches of mathematics because we talk about area. In a bar graph, you can't talk about area in a bar graph. Histogram, the bars are going to touch. So that's another way, if I asked you to draw a bar graph and you had the bars touch, you'd miss points on that. You don't want the bars to touch. Histogram, the bars are going to touch. But the overall, the same concept. What's the frequency? Mark it up, and you have a height. Right?
I never knew the reason why histograms were histograms.
You just thought they were bar graphs?
I thought they were just like special bar graphs that
Yeah.
touched. And
Yeah. The reason why they touch, you guys see that there's no overlap?
because it's like continuing.
Yeah, if I
basically.
said if you were, 18 to 20, 20 to 22, type thing like that, then if you fall in this category, you're going to be in this bar graph or this height. If you fall in this category, you're kind of in this height. So looking at categories versus classes. Question.
Oh, I wouldn't you just use like a line graph?
You can do a frequency polygon for this exact same problem. That's the next problem we're going to do. And the thing you do here is you find the median, and you put a point. You find the median, put a point, and then you connect the 2 points. And that would be a frequency polygon, which is used a lot of times in algebra and stuff. You talk about slope, and that's rate of change between one category to another category. So you can visually see which is the largest rate of change, which is the largest increase, and which is the largest decrease. With lines, you can actually come up with points and find an equation and find the slope, but we're not going to go that far. We're just going to do a frequency polygon. Right? Pretty basic, right? You just, it takes a lot of time if you want to make it really nice, which I don't know if there's a lot to kind of test you on that. This is the exact same data, except we're going to do a frequency polygon, right? So the only thing we actually need to do on this is find the midpoint. So to find the midpoint, you add the two numbers together and divide by 2. So the midpoints are given as 1.255, 1.755, 2.255, so forth.
So would we still put class and frequency?
You would put closing price, because you would actually put closing price on this one as well. The class is just what they fall in. That's the closing price, the frequency of which it happened. Here, we say the closing price, we put it on the midpoint. And if you would have, if we would have a bar here, a bar here, a bar here, a bar here, this would just be the midpoint of every bar.
Okay.
Right?
Can you go back to the last one? There.
Oh,
That one.
Yeah.
this one?
Yeah.
Which one is this?
This one is the frequency polygon, the exact same amount of data, except now I just need to find my midpoint. So if I have my frequency, let's say I have my bar graph. On the exact same bar graph, you can draw a frequency polygon, and it actually makes more sense to see it that way. So if I have, so I have 0, 1, 2, 3, 4, 5, 6. So for my bar graph, I would have 1.01 to 1.5. So I'd have 1.01, 1.5, 1.5 to 2, 2. So my first frequency or histogram, frequency 1, 2, 3, 4, 5, 10, 11, 12, 13, 14, 15, 16, 17, 18. So for the first one, from 1 to 1.5, go ahead, say 1 to 1.5, I had a frequency of 1. From 1.5 to 2, I had a frequency of 18. From 2 to 3, no, sorry, 2 to 2.5, frequency of 14. Over here. What? Yeah, that's what I'm showing. This is what we just did with the frequency diagram. Now for the polygon, for the frequency polygon, instead of having a bar, I have a point. And the point is the midpoint between 1.01 and 1.5. Right? To find that midpoint, I take 1.01 plus 1.5 divided by 2. I plug that in my calculator, and that gives me that point, 1.255. And then I put a dot. Okay. Then I have to find this midpoint. This midpoint is going to be 1.755. This midpoint is going to be 2.255. This midpoint is gonna be 3.2, oh, sorry, 2.755. So I'm finding the midpoint of each class, and then from that midpoint, I just put a dot that represents the frequency. So I have this dot, and this dot, and this dot, and so forth. Then yeah, it's a frequency polygon. So in between each dot is a line. Poly means many, gons mean sides. Basically, you have many lines there.
Wait, this is a stem leaf plot?
The stem and link plot is given. This is a stem and link plot, kind of. So, and then there's what you can put 0. Typically, they go from 0. Except, remember what? I guess they keep the same size. So it's at 0.755. But that doesn't really matter if you put that point or not. They draw it down to the x-axis.
So do we erase our bar? Which is it?
What?
Well,
These
they
will
don't
be-
have that- they don't have
This
that.
will be kind of two separate questions. Can you do the frequency histogram, or can you do a frequency polygon?
Polygon.
Frequency distribution is given. Frequency polygon. So here there is actually a little bit more calculation you have to do. Bar graph is the simplest you really get, because you have categories. There's no midpoint of a category. And then you have the frequency histogram, and a histogram will look just like a bar graph, except the bars will be touching. Frequency polygon, you don't have bars, you just have lines. Question.
Okay, so on the, after the 4.01 through 4.50,
Mm-hmm.
on the.
They go back to the.
frequency, yeah, they go back down into, do we have to complete it and go all the way back down to the x-axis, or do we just leave it?
In a frequency polygon, they want you to touch the x-axis from the beginning and at the end.
Okay,
Because it's a polygon, so you want a closed figure.
okay, so when it's like done cut off, we just,
Yeah, you just go down.
okay. I understand.
Just like you start at down and then you go.
Yeah.
So frequency polygon, your polygon needs to be closed. So you start at the x-axis and you end at the x-axis. Your last point will just go down to the x-axis.
Even if that point doesn't exist. on it.
It technically, because I mean, it doesn't close at 0,
Right.
but yeah. Basically to say that it's over here, that there's no more things going on.
So it's just gonna continue.
Yeah. And a frequency polygon will always have a start and an end. But not all graphs necessarily will. Time series graph is collection over a period of time. So here we're looking at time is changing. Identity theft has increased, more people shopping online. So the number of complaints in thousands and the year the complaint was made. So we do the same type of thing, except this is a smooth curve because it's time. Time is continuous. Here, from here to here, there's nothing happening in between here. You can't really necessarily calculate this amount. It's a direct dot, it's a direct, from this dot to this dot, it's a straight line. It's a single slope. From this dot to this dot, it's a single slope. Here, it's smooth though, because time is changing. Question.
How did you get, what did you do to come up with the first dot?
This dot?
No.
This one?
Yes.
I just went down to the x-axis.
So it doesn't
You
matter
could
where
go
it's at
here.
on that
It doesn't
line?
really matter. No.
Okay, all right,
No, you have to start and end on the x-axis.
okay.
So you can go here and then you would end somewhere down here. So here, number in thousands, and then the year. Anytime you're dealing with in time, on your x-axis, you're going to have a time series graph, and it's going to be a smooth curve versus a polygon. In a polygon, we'd have this line, this line, this line, this line, this line, this line, which is kind of what we get here, but it's going to have a little bit more continuous with it, a little more smooth curve with it. These line segments, as you kind of zoom out over time, they get smoother and smoother. You guys have probably seen that with stock market prices. If you zoom in, it's really kind of jagged. And then you zoom out and you get these nice smooth curves. So the main thing to go over the difference between a bar graph and a histogram. The pie charts or the pie graphs are kind of on their own little category. Being able to find the angle in the pie graph, that would be a much more realistic question on a test, is what angle would this piece represent? What percent of the pie does this piece represent? So you wouldn't have to do the full-blown pie graph. You would just have to be able to find what percent of the pie it's going to make up and what angle that piece would be. So if I gave you the pie graph, and I might say this is the always, what percent of the pie is that, and what angle is that? If you know one, you know the other. Or you can find the other, you can calculate it, right? So for frequency over n times 360 gives you your angle, and your frequency over n gives you your percentage. So this would be the percentage of the circle, and the circle is 360 degrees. So they're related there. Okay, so I know this section is just very time consuming by making these graphs, but it shouldn't be difficult. And the application is, there's not a lot of application as far as, can you identify a histogram? Can you identify a bar graph? Can you identify a frequency polygram and a time series graph? And a pie chart, hopefully there's matching. It wouldn't be too difficult to do that. When you use them, as I said, here's a setup. What graph would be beneficial here? The bar graph and the pie chart are very similar. A lot of times people show both ways. Here's a bar graph, if I polled everyone here their favorite animal is a cat or a dog, horse or an elephant. I could do that in a pie graph, or I could do that in a bar graph. Typically, those are kind of interchangeable. Okay, so just for next time, since we have a few minutes, we're going to do the measure of averages. And again, it's going to be kind of a lot like today. Sometimes actually calculate, if I give you 15 numbers and actually ask you to calculate the mean, you just take 15 numbers, add them all together, divide by 15, and find the mean. That can be kind of time consuming. The median is going to be the middle number. So if I give you 50 numbers, you have to write them from smallest to largest and find the middle number. So that can be time consuming as well, depending on how the data is represented to you. Mode would be most often. Again, that can take some time to verify if you have quite a bit of numbers. You're searching, oh, there's 77, there's 77 again. So sometimes you'll see, I'll actually give them to you in maybe frequencies. So if I give it to you in frequency, the mode is really easy to see here, right? The most often. The median is going to be, again, relatively easy to find. The mean is going to take some time because we're going to have to add up all these different things, and there's different ways to do it.
Wait, don't we add it up and then divide it by?
Yeah, but here we have classes. So we have to find the midpoint of each class. And then once we have the midpoint, we take that times the frequency, add all those numbers up and divide by total amount of frequencies we have. So the concept is the exact same as what you did in middle school. The application is going to be a little bit more difficult because they're not going to be, here's, 10 numbers. Find them, the median. It's going to be this setup. There's 18 that are between 1.51 and 2. So you find the midpoint of that, take that times 18, and then add. And so what we'll do is we'll have charts like this. We find the midpoint of each one, the frequency, multiply those two together, and that will give you the frequency times the midpoint. Add those all together, and that gives you the sum. Divide that by the frequency sum, that would give you the mean. Median, some of these will be pretty straightforward what the median is. Again, there's different ways to represent your data points. Days and frequency. Sometimes you'll be given a list like 10, 10, 13, 10, 13, 15, 13, 12, and it will make a lot more sense to put it into almost a frequency diagram. Then you only have 5 things to worry about, and then the frequencies are given. Some of them will be pretty straightforward. Modes, you can have more than one mode. You can have 0 modes. Mid-range, again, is going to be calculated as the lowest number plus the highest number divided by 2. And then a lot of the application in this section is comparing mean, median, mode, and mid-range. Those are the 4 kind of averages and what it means. So if I give you guys a test and half the people got 0s and half the people got 100, I said, oh, the average on the test was 50. Would that tell you much? Well, unless I told you maybe the mid-range was 50, or I told you some information there. So we're going to talk about when's it best to use median or mean. A lot of times I like the median because it tells you the middle. So you're above the middle or below the middle. Kind of, it cuts the data points in half and tells you kind of where you're at. If you had 10 100s, and then, it's going to move up that median. Mean is just the average. If you add them all up and divide by a number, we'll talk about the strengths and the weaknesses of each one of those. But again, not a lot of new stuff here. Probably nothing new. You guys have done all that. The application might be a little different when I give you the mid-range classes, where you have to find the midpoint, take that times the frequency, add all those numbers together. So you want to bring a calculator the next couple of class sections to. And again, we don't have a lot of time in class to do a lot of those calculations. So you can just kind of take my word that this number times this number is this number. The sum of all those numbers is this number. It's really frustrating because if you hit a wrong number in your calculator, you did all this work and you have a wrong answer, it takes some time to kind of get used to that. So, so far we really haven't done much new stuff probably for you guys. And you can imagine how I'm kind of have to test it. If there's going to be, there's 6 sections on this next test, so be evenly distributed. So some of it will be very basic and some of it will be a lot more in depth. So keep that kind of in mind as we go forward. All right, I'll see you guys on Friday.
You should make a big